We are recording.
I would like to welcome you on INNOVER webinar dedicated to energy efficient data centers. And my name is Andrei Somov. I am a senior researcher at GreatNet Research Center. Actually, I would like also to introduce our speaker, Giovanni Giuliani from Hewlett-Packard Italy Innovation Center. He is a technical coordinator of DC4Cities project on data centers, and he actually has been a technical coordinator for another on data centers, the projects such as Fit for Green and All for Green. And he has a wide experience and strong background in data centers, and currently he's a master architect at Hewlett-Packard in Italy Innovation Center. Just a few reminders for you. So please mute your microphones to avoid the noise during the webinar. You to prepare questions and ask them after the lecture. So, and Giovanni, please.
Thank you. Webinar. Thanks, Andrei, for inviting me to this. We are with this project to INNOVER-EAST, and thank GreatNet and Europe Alliance for Innovation for this setup. Andrei already said, my name is Giovanni Giuliani. I work in HP Italy, and today I will present to you the DC4Cities project. One of the last framework program 7 project in the context of a smart cities goal. So it's a project around data center energy in the context of smart city, and it's a very interesting link between these two things: smart cities and ecologically, environmentally sustainable data center. So, and we will definitely explore the link in the context of a presentation. But Andrei said the project has origins some years ago. Started in 2009 to prepare some proposals that have been accepted by the European Commission during 3 different framework program 7 calls. The first one was related to a project aiming to save energy inside the data center by performing dynamic consolidation of virtual machine and simply turning off the servers that were not used. It was the basic idea of Fit for Green project. We started in 2010 and we completed the project in 2012, and I was part of this project. That's where we have been working together. Was interesting and gave good results. So we decided to make another step forward, and we started in November 2011 a new project called All for Green, where we were trying to exploit the benefit of having green service level agreement, flexible service level agreement, providing a data center a certain set of flexibility, and utilize this flexibility on one side to save energy in general, on the side to help the energy provider during peak times in order to avoid the energy provider to go into crisis mode. Therefore, either to put because when the energy provider is in peak mode, they need to use fast urgency energy sources like diesel generators, but put a lot, on the other and most catastrophic scenario, to have a blackout, and times happen. So, in order to avoid the energy provider to manage this emergency situation, the data center could exploit the flexibility, help to avoid, in the context of a global collaboration between all elements inside the ecosystem, to avoid this situation and create a better environment. That's basically the origin for the name. All together, all this collaboration between all components in the ecosystem. Started September 2013, a new project called DC4Cities. So a data center that is friendly enough to be a participant into the smart city scenario. Here we want to adapt the consumption of a data center to the availability of renewable energy. The renewable energy you have, the more the data center can work and utilize the power. When there are few energy available, the data center should try to minimize its consumption. With inspiration from HP Labs' Net Zero project in California and from the Parasol project carried out by the University of Barcelona and the University on the East Coast in US. So our origins. And the project I will be talking today is, again, I repeat, DC4Cities and city calls. Need to distinguish themselves from other cities because they offer special services to the citizens and they optimize the execution of their process so that they reduce the amount of resources they use to provide the services to citizens and to process they execute inside the city. I'm not talking explicitly on IT processes, but also garbage collection, traffic, etc. are processes managed by the city. And this process can be optimized through usage of IT. So, smart city has a large dependency on IT to deliver IT services, good IT services to the citizens, and to optimize their other physical services. So smart city typically should have to use IT and therefore data centers more than other cities. Problem, the more you use data center, the more power consumption you have. So the negative side effect in terms of resource usage and pollution. That's the reason why the EU in this call working for data center with smaller environmental impact to meet the objectives of the smart city in terms of sustainability, because the itself from the services they provide, but also for the quality of the life that is strictly related to the quality of the environment where the city is located. They're interested in having sustainable data centers and improve the effectiveness of from environmental standpoint using specific metrics that currently don't exist. We are working also on the idea to create new metrics and energy efficiency of the data centers, and we'll talk later on about them as well. But let's go back to the basic concept of the project. The data center needs to become somehow energy adaptive. Needs to know what is the availability of renewable energy and try to adapt its own power consumption to that availability. And if a smart city has special requests for the data centers in terms of energy, because the smart city has an authority that is coordinating the use of the energy inside all domains of a smart city, the directive needs to be accepted and the data center needs to be adapted again also with respect to this constraint arriving from the smart city. So the bottom of the picture. And the surface represents the renewable power, for instance, arriving from a set of solar panels dedicated to the data center. The power only during the day. A data center that has less flat consumption with some variation during the day will be able to utilize in the best possible way the renewable power. You can guess that 50% of the data center consumption, the brown line, comes from renewable and 50% comes from the grid without the help of this renewable, because they grown when renewables is not available. In the right-hand side graph, you see there is a peak of consumption of the data center, the green curve, that is in sync with the maximum of renewable power. So the data adapting itself and in sync with renewables, and at the end of the day, it will have 80% of consumption covered by renewable power. This is one in two pictures. The situation and what we would like to do in the project. Try to shift our peaks sync with the availability of renewable power. At the end of the presentation, if you want to go and take a look at our website, you will find a lot of documents and additional information. The website name is www.dc4cities.eu, and below you see the logos of the partners participating to the DC4Cities project. HP is a big industry. On the left-hand side, Freemind, a small and medium company in Belgium focused with management systems and especially oriented with to renewable energy. The coordinator is in Freemind. Then up on the left and on the right, two universities, Mannheim and Passau in Germany. On the left, on the second row, we have CreateNet in Trento, participating to the project, together with INRIA on the right-hand side, in Nice area, Research Institute. Barcelona and its data center providing services to the university in Spain. Here is a large research center in Italy that has a special interest in renewable energies. And Fenosa is actually an energy provider in Spain that it has generation both from traditional fuels as well as big plant hydraulic production and some photovoltaic. In this introduction, Barcelona municipality on the right-hand side of the HP logo, because the city of Barcelona itself is participating to the project in two ways. It offers one of its own data center to participate as the trial together with HP and CESUC ones, but it will represent also the smart city as an authority and coordinator of this kind of energy management activity. Having inside the project one of the most active cities to be the European representatives of smart cities is definitely a good plus for this project. Look at the project itself, the technological part here. Basically, I said we want to have a data center that you see in the middle. Also, we developed a controller for data center in the picture This controller wants to adapt the consumption of a data center to the availability of renewable resources. So it needs to know what is the current component of the production of the energy and what is the forecast for, let's say, for the next day in terms of production, availability of renewable energies locally produced or from the grid. And it needs also to interface the smart city to receive the direction on how and when to use energy. The controller will have an interface that we call a renewable energy adaptive interface, the green bar at the top, through which it will talk to and providers of energy and to the smart city to retrieve the information that become the guidelines, the guiding principle in order to tune the consumption of a data center. But the data center is the consumption of the computers and the other equipment in data centers. Computers will run a different kind of application. The idea is to tune the execution of the application, but use IT resources, computer network, etc., and tune the execution and use the minimal amount of equipment necessary to fulfill the job and try to use the maximum only when we have the peak of renewable energies. Otherwise, try to minimize. And that's the reason why we have this above the bottom or in the central part of the picture lower than the data center is facing the adaptive data center operational interface, the core module for the different software. A work package dedicated to scenarios and especially concentrating on the top part of this picture. We have 3 different technological research work package. One dedicated to the controller, work package 3 in the center. One dedicated to the elements that will provide information related to the energy for and the energy usage constraint, that is work package 4. And work package 5 in the bottom that will orchestrate the execution of a different software component in line with the direction received by the controller. Related to the free trials, where we'll try to implement as much as possible of this large scenario prediction in real cases. And we have later on a little about the trials. The picture to a bit more schematic view. What we do on interface, the renewable energy forecasting interface that we also call northbound interface, because we consider the northbound system the one where energy is produced, and with respect to energy are generated. We expect to have kind of connectors that allow DC4 system to collect information and forecast about the energy power from the energy provider. Some of the energy providers in Europe expect this data in almost real time. There is a site in UK where you can connect and have and receive every 5 minutes the energy in UK. There are services like this in Spain. The providers have this also real-time data. Anyway, the details, how the information is structured, depends on the provider. So we created this kind of connectors that will go and have to retrieve the data and convert them into a unified format. available, we try to make forecast even if we don't have the provider of this data. Let's think at a set of solar panels installed on top of the roof of the center. Installed, directly connected. They're no providing us the information about the forecast of how much they will produce during today and tomorrow. But the of solar panels might be strictly related to the web forecast. We created connectors to this environmental data, and we try to correlate to create a local forecaster to provide the for the next day. And go back. Utilize this forecasting interface for all the possible providers, direct or indirect. We would be very happy that this interface becomes a standard, and therefore will directly use this interface standardized to provide data as represented by the yellow dot arriving to our system. For the sound interface, current software controlled by automation tool monitoring and IT automation tool, but the software is not energy aware. There are some controllers to utilize the monitoring and automation capability of the software application and services to control their behavior. If it's a standard, we standardize this approach and make this interface ubiquitously available on the different software packages and services. Something like NTP applied to or the energy concept, just to provide a rough idea. Let's make a tour inside our system to see how we work with this information. We connect to the smart grid or the grid, and we retrieve the first graph that is on the left-hand side, data of graphs. So the energy availability forecast based on the different fuels, resources. In this picture, for instance, in green is the portion from panels, then the eolic is in light blue, then we have gas and coal. Gas and coals are not. If we do a couple of maths, you end up computing the REN percent, the renewable percent for the grid. And based on the amount of sun and wind compared to gas and coal, the renewable percent will vary hour by hour during the day. That we might have on the top of the roof, we can take a look at the weather forecast, solar radiation, and estimate about the power will produce by the solar panel. From the goal to stay 80% of renewable. Target for our optimizations. The compute a sort of the maximum of power consumption curve, but with the availability of energy from different providers. Of power will be split using special splitting policies into amount of power that each one of the service running inside the data center will utilize. service B and C, yellow and red, are applications that needs to produce a certain amount of work. For some reports or convert videos, a certain amount of videos, while a service like the blue one is one that is always up and running, for running with its own quota for execution. Now, at this point, is a very important step that the controller of a service will need to tune the execution of a service itself in order to have an assumption of the IT resources used in order to implement the service, and the consumption of this IT is computer, network, etc., needs to have the shape and the value expressed in this plans. This is not easy to do. Therefore, you have an example of how it can be accomplished. But the application needs to run or process 20,000 files. To do that, the application needs to do every day. To 20,000 reports, they be files to be converted to one format into another. So you have 20,000 of these files to process. You have different options to do the work. You, for instance, utilize 5 machines. For example, could be you have this amount of files to scan for this, so you can have 5 antivirus machines running in parallel. You can process 10,000 files per hour. So 5 files to do. The machines, you can complete the work in only 2 hours. And this is the beginning of the first graph top right. Instead of using 5 servers, you could use 2 servers only. In that, you'll be able to process only 4,000 files per hour, but you needed to take 5 hours. Alternative was C. You have in 1 hour using only 1 machine, then for 2 other hours you use 2 machines, and for yet another hour you use 5 machines. The usage of resources will be different during the time, and will have a different shape of your curve. Organize the physical machines or the virtual machines to produce the amount of work you need to do during the day based on your service level agreement is working mode. You can be aggressive working mode lies in case A, or flat, almost flat distribution like B, or varying working mode with peaks and periods where you use low resources. So, possibility, this different possibility, the controllers of the software running in the data center, each controller will create a set of alternative plans, option plans, that try to match the budget in terms of energy they have received. On the other side, we'll try to make sure the service level agreement are respected. But try to approximate the budget, the energy budget, but also have some exception. They are not all 100% compliant, but I try to tend to have shape of that they have received, and the possible alternatives are all returned by controllers. They are aggregated by an optimizer that will select the best possible combination of all the proposals received by the adaptive software controller is a single combination that will try to be as similar as possible to the maximum ideal power consumption, the total one, and will respect the constraint from the smart city administrator. One solution to this big complex problem has been found. It will be shared and visible from the data center energy administration from the dashboard of the system as well as from the smart city administration, at least so that the smart city can have a view on how good the center has been in respecting the guidelines and the constraint about energy usage. How our controller is working. It will be easy to respect the goals. Sometimes it will be harder. Sometimes maybe there might be also exception in case it cannot be achieved. Exactly the effectiveness of our controller. Most known and sometimes also used measure related to data center is PUE, power effectiveness, which is not a very good metric in my opinion for the of optimization. The P is the ratio between the total power consumption of the data center and power consumption of the IT equipment inside the data center. So total center including air conditioning, UPS, lights, etc. How much it's spent by the computer themselves. The value that is to 1, the better. So that was well over 2.5. And so there was a lot of overhead spent by the air conditioning and UPS, amount of energy spent by the computers. Most data centers have a PUE of 1.25 or even lower. The world record is around 1.15, 1.2. These are very good optimized data centers. Anyways, they always measure only the overhead of the air conditioning, the facility, compared to function of the computer. They consider in this metrics and in many other metrics what it's doing in terms of work. For normal people, it would be very important to understand, like cars, done by the data center divided by the power spent in order to do that work. If investment of the cars, the consumption, the fuel consumption, how many kilometers you do with 1 liter of fuel. You generate each meter you do. So compare the work done, the useful work done for you, move from one place to another, to consumption or the energy that has been spent by that specific car. And proposing to do the same. Try to analyze the work done by the data center and how much energy is produced. Sometimes in the newspaper, you see article saying Google data center is consuming X watts for each search that we do all around the world. There has been a recent study by a French research agency for energy. It costs in terms of energy and in terms of emission sending out emails. That's what we are interested in. How much does a web server, a web consume for each web request, for each web page? In such a metric, we can try to different data centers, and we can bring awareness to the users so that when you will buy your own website from a web service provider, you ask, how much are you consuming? How much are you emitting for 100,000 pages on the website? And you also select based on price, for sure, and also from kind of emission or energy perspective, the best and most effective service. Let's investigate, and we're a bit ahead of what the typical standards do. Never collaborating inside the cluster of different projects, research projects from the EU working on data center energy optimization, together working in making standardization proposal for new metrics to the European standardization groups. With the grid, which is advanced on this kind of topics, and very important topic for us. About, because time is going on, we have one Trento of an application related to health that is generating reports for the system, and the application is located in Trento. We have a very nice application that is inside Suzuki, is offering service to basically. It's the cultural inheritage system for Catalonia. They collect all the web contents related to Catalonia, they convert it into a common format, store it and redistribute it to web, so that whatever event happened in Barcelona or has happened in the past will always be stored in this central system. And in Milan at the HP site, we have a site where we have put solar panels on top of the roof, have a special hardware at very low power consumption, and we are running a web application, a wide application for e-learning web interface. So different kind of applications. I will a bit about ours because it's probably a complete set. We have solar panels on top of the roof, only 8 solar panels for kilowatts. P, an external provider for the night. And we have deployed a complex application, quite complex, sophisticated application on a set of moonshot servers. These are one of the newest hardware at low consumption. They are radically different from the traditional server because they have been designed with our consumption in mind. They are like the one on this picture, but is the one that we installed in our site when we did the kickoff. I took this picture. And board horizontally placed on top. These are the cartridges. It is one server. Power consumption servers slightly lower than the best breed, but they are very efficient. And also, these cartridges can contain up to 45 servers. Have special things in order to save energy. They put whatever possible in common so that each server is really streamlined and all the fan, power supply, etc. are optimized and shared by all cartridges. Just to give you an example what it means to use instead of a traditional system. HP.com website, 300 million hits per day, 3 million web pages per day, was 46 legacy servers in the center in US and was consuming 115 kilowatts. 115 kilowatts for a day. To make a comparison, 3 million hits per day divided by 115 kilowatts it's the kind of metrics we are interested in. Now, all websites have been migrated to moonshot system, 6 moonshot chassis, and total power consumption is 6 kilowatt, 6 compared to 115, and still performing exactly the same work. They are covered with the same response time. So 4% less power consumption. That's the reason why I say it's radically different. And we've installed this on our site. It may be why are we talking about a learning application? Because it happens that we are managing this service worldwide for HP. It's a web-based with over 100 students connected. And, we are deploying the production machines on 3 different clouds all over the world. The application running on these 3 different clouds, and we have put them in 15 different cartridges. What HP.com does with its own web servers, we did with this e-learning application. So we have put this inside our trial, powered with the solar panels that you see the pictures of the 8 solar panels on top of the roof, the inverter, on the right-hand side the controllers, and one screenshot of the output of the solar panel controller. You see that was a quite good day. And the yellow portion, the yellow surface is the production of the solar panels. The green colored one is the power consumed by the moonshot from the solar panel. The red portion is when sun was not available, we were drawing power from the grid. 8 solar panels on top of our roof, we have been saving 1.5 tons of CO2 emission in 1 year. Just if you want to have an idea of the CO2 impact. This is the last slide where I recap the trial results. We production of EVs under different kind of days, and we found common patterns. And here on the left and on the top graph, you see the typical 5 representative of typical days, some good ones and also not so good ones. On the right-hand side, you see that we're running an application. The application was application of HP Live system in a baseline mode with all the moonshot, and the red line is the consumption, the total consumption of the moonshot, being heavy workload for this web e-learning application. The yellow surface is the production of the solar panels. The surface is the renewable percent of the grid in Italy for that same day. You see that it's varying hour by hour. The picture represents 24 hours. Have a very good view on what we did. The red line is the consumption of the application as is our baseline. By utilizing the optimizations of DC4Cities, the total consumption was the line that you see below the red line. The red blue line match in the top consumption peaks when there is a lot of load. When there is less load, we see some of the moonshots that are not necessary, and therefore we save energy. Our REN percent, the renewable percent, improved between let's say 4 and 6%, depending on kind of day. One is a very good day, so it was 6%. On favorable weather condition, we still improved by 4% our renewable percent. Power consumption was reduced about 13%. Efficiency of the service we deliver in terms of web page request per watt improved between 12 and 16%, depending on the different days, profile days that we have been shown on the top left. Successful for phase 1, we want to get even better number for phase 2. Just information, this 50 cartridges plus 2 load balancers that we used consumed in total 500 watt. Watt is average consumption of 2 lead servers, 17 physical machines. So you can understand very important for this trial with only 8 solar panels to have servers that don't consume much. Otherwise, this contribution of the solar panel would not be enough for the servers. But for moonshots, 16 moonshots were powered very well by only 8 solar panels. But Andrea will tell you to see if there are any questions.
Okay, I think it is very interesting. So, does anybody have questions? Okay, all the renewable energy providers. So I'm just curious, we are interested to have long contracts with the data centers, because we're not sure that they can provide enough long period of time, and whether this business is already on the market or not.
Point, because if you are small and you are given to such a critical service like the data center, very bit sad kind of contract. What I've noticed is that typically data center don't take the risk to get only one provider. They are data center that are not connected to provider, but in general, some of them make 2 contracts with 2 separate grids, or as an and emergency generators. But some data centers are trying to make a contract with small local provider as an additional power supply, not at the main. And not being the only provider, local provider, not being the only one, makes it easier. Because it will be the preferred one where you have power. But if they don't have enough power, they will not break the system, because there will be a secondary power provider. In evidence of some data center and in Bologna, solar panels through a local provider, some the turbines, little ones, not big ones, and a contract with a provider that will give you 100% renewable energy. Obviously, not in real time, but average, like the green tax and the certificates, with authorization to use maximum renewal in real time. They average over the day. Never they generate that amount of production from real. Anyway, by using 2 different sources at the time, they can reach very good numbers.
Questions from the audience? one more question. Well, I remember there were hot discussions regarding the exploitation of nuclear energy, because in France they have pretty many nuclear plants. And the question is, do you deal with this kind of energy, or you do not consider it as a green type of energy in this project?
We took the position that we do not count nuclear as renewable. It's a convention, because as you remember from the slide, let me go back quickly, slide where we had, we receive the graph you see on the left hand side, the numbers for this graph. Compute how much of this is renewables or not. We consider nuclear as renewable. Therefore, in our computation, we count on other kind of energy sources. In France, there's a lot of nuclear production. This depends on your ecological sensitivity to it in one category or in the other. The people in this project have a attitude for that, and so don't like too much the nuclear production. For we try to make to do the best we can without using it. It's a conventional. I agree with you.
Yeah.
It's a convention. For us, is yet another source of energy. At the end, we take all the sources and we categorize as renewables or non-renewables. We do not consider them as renewable, but it's it depends on for the optimizer, etc. It's irrelevant.
Participants, it would be interesting, just for the sake of curiosity, what type of ambient energy is the cheapest one, let's say, for wind?
I've got also an interesting question. Do you think that at the end of the day, it buy panels instead of a grid, will the data centers spend more because renewables, or?
Well, the question, because the equipment.
It's a very tricky question. And when in some countries there are tariffs that change the price of the energy based on the hours. Energy cost for big consumers like data center, energy costs less during the night compared to the day. But at the end, if we try to use more energy during the day because there is the sun, and more, or and we are also trying to make this kind of evaluation, and there are metrics related to the economical impact. There are two ones. One that is related only to the consumption and the tariffs of the energy based on this optimization to see whether we don't incur extra costs. Or even more complex one where they look at investment, how much it costs to put solar panels and utilize them for free. And are also considering inside the cluster the standardization, the of metrics are also considered. So we take price also in consideration.
The problem lies in equipment and the problems from technical point of view, because you cannot sometimes directly, provide renewable energy to the load, and therefore you need to store it somewhere. And if you store it, of course, there are some leakage currents, and you also waste the energy. also considered?
The storage technology was not mature when we planned for this project. Is becoming more and more interesting, and this kind of optimizer might very interesting contribution. This might be a good topic for a next project, I guess. How to storage in the best possible way.
Like supercapacitors and batteries, and you should find a trade-off between leakage current and, of course, number of cycles to charge and discharge the storage. Yeah,
a good topic for a follow-up project.
We'll join you again. We'll see. Does anybody have a technical or just curiosity? Questions? I would like to thank Giovanni and Packard for this interesting presentation and webinar, and thank you for answering questions. Participants have questions, perhaps we'll ask in offline mode.
Okay. Question, and then like another then by email with you.
Yeah, Giovanni, we can stop recording.
There's a question in the chat, probably.
Yes, regarding when the webinar will be put on. Oh, well, hope it will be online within 1 or 2 weeks.